One jar of Nutella contains the result of a process so precise that even a difference smaller than a grain of sand can change how it feels on your tongue. But here is the real question. Why does Nutella taste impossibly smooth, even though it's made from one of the hardest nuts in the world? Inside this factory, hazelnuts are exposed to temperatures carefully calibrated to unlock hidden flavor compounds, crushed by multi-ton rollers until their particles become nearly invisible and blended under conditions food engineers guard like trade secrets. Yet something even stranger is happening here. Every jar must taste exactly identical, whether it's opened in New York, Tokyo, or Paris. No stronger, no weaker, no grainier. Perfect every single time. How do machines control something your own tongue can detect instantly? And more importantly, why has almost no competitor been able to replicate this texture successfully? Today, we step inside one of the most tightly controlled food production systems on Earth, where chemistry, physics, and engineering quietly work together to manufacture the spread millions are addicted to. Stay with me, because near the end, you'll finally see the microscopic secret that makes this texture possible. Long before a jar reaches a supermarket shelf, the story begins thousands of miles away in hazelnut orchards, where climate, soil composition, and harvest timing quietly shape the future texture of the spread. But not every hazelnut earns a place inside this factory. Shipments arriving here are examined with extraordinary discipline, evaluated for size consistency, internal moisture, structural integrity, and aromatic potential. Because even minor agricultural variations can echo through the entire production chain. Too much moisture and flavor weakens. Too little and roasting behavior changes, allowing bitterness to emerge.
Food engineers aren't simply buying ingredients. They are buying predictability.
When your goal is identical taste across millions of jars, randomness becomes the enemy. So only the most reliable harvests move forward.
Which raises an intriguing question. How do you unlock flavor trapped inside something naturally this hard?
Inside massive rotating roasters, hazelnuts are exposed to precisely controlled heat, triggering the Maillard reaction, the same transformation responsible for the deep aromas of toasted bread and roasted coffee. This is the moment a raw nut becomes flavor, but it is also a moment of risk. Roast them seconds too long and delicate oils begin degrading. Too lightly and the flavor never fully develops.
Sensors track thermal behavior constantly, ensuring heat penetrates evenly from surface to core.
As the skins loosen and separate, the air itself transforms. The factory no longer smells industrial. It smells unmistakably like dessert. Yet flavor alone isn't what made Nutella famous. Its reputation was built on something else, texture. And achieving that texture requires something surprisingly violent. The nut must be completely destroyed. To create silk, engineers must first create chaos. The roasted hazelnuts enter powerful grinding systems designed to fracture their cellular structure. As they collapse into a dense paste, natural oils are released, forming the earliest foundation of spreadability. But at this stage, the mixture is still gritty, still imperfect, still far from what your tongue expects. And that leads to a surprising realization. Smoothness is not natural, it is manufactured.
So how do engineers eliminate a texture the human mouth is remarkably sensitive to?
The answer lies in entering a world measured in microns.
Your tongue can detect particles larger than roughly 20 microns, so the factory builds a product smaller than that. The paste moves through multi-ton roller refiners, compressing the mixture again and again, until particles approach invisibility. Imagine crushing something until it disappears from human perception. Every pass brings science closer to sensation. Too coarse, and the spread feels sandy. Too fine, and the mouthfeel becomes strangely heavy.
There is a precise threshold, a narrow zone where physics aligns perfectly with biology. Hitting it requires mechanical accuracy few industries attempt.
But Nutella is more than hazelnuts. Now, the system must transform this microscopic paste into the flavor recognized across the planet. The recipe may be famous, but the real secret is how it is blended. Cocoa, milk components, sugar, and oils enter in carefully engineered ratios. Yet what matters most is not just what goes in, it is when it goes in. The sequence, the sheer forces inside industrial mixers, the controlled thermal environment guiding viscosity. Because once structural crystallization begins, there is no rewind button.
Engineers monitor resistance within the liquid itself, ensuring the mixture thickens gradually rather than unpredictably.
Still, even perfect blending does not guarantee the texture will survive, because the next stage quietly determines everything your tongue will experience. At this stage, Nutella may look finished, but in reality, it is dangerously unstable. Inside the blend, billions of microscopic fat crystals are preparing to solidify. How they form will determine whether the spread feels luxurious or disappointingly waxy. Too fast and chaotic crystal networks develop. Too slow and separation can begin, allowing oils to migrate and undo months of precision. So the factory turns to thermal choreography. The mixture travels through vast stainless steel heat exchangers, where temperature falls in carefully staged phases. Not sudden cooling, not guesswork, but a controlled descent designed to guide crystal formation into ultra-fine, stable structures. This isn't simply cooling, it is molecular sculpting. Sensors watch continuously, because even a few degrees of deviation can rewrite the final product. And here's the unsettling truth. If temperature control fails now, the flaw might not reveal itself for weeks. Only when someone twists open the lid.
So how do engineers detect failure before the world ever sees it?
Behind the production floor are laboratories that feel closer to pharmaceutical environments than food facilities. Here, batches face relentless scrutiny. Viscosity is measured to confirm the spread flows exactly as expected. Laser instruments analyze particle distribution down to microscopic ranges. Aroma is evaluated because humans don't taste with their tongues alone. We taste with memory. Then comes one of the most fascinating safeguards of all: trained sensory panels. Individuals whose palates have been calibrated through repetition to detect differences most people would never notice. Imagine tasting two samples that seem identical and recognizing one is subtly sharper, slightly flatter, almost imperceptibly grainier.
At this scale, almost identical is failure, because one drifting batch could ripple across millions of breakfasts worldwide.
Only when chemistry, physics, and human perception agree does the product advance. Now comes the next challenge: protecting perfection while moving at extraordinary speed.
What you're about to see is a balance between velocity and absolute control. Finished Nutella flows toward filling lines as thousands of empty jars approach in synchronized motion. From above, it looks effortless. Underneath, engineers are fighting turbulence. Pouring a high viscosity spread is nothing like pouring liquid. Flow must remain continuous. Air pockets must be prevented. Surface disruption minimized. Even nozzle height is engineered, avoiding micro splashes that could trap oxygen and shorten shelf life.
Watch closely and you'll notice something mesmerizing. The stream never breaks. It folds into itself like satin ribbon.
Each jar receives nearly identical mass within fractions of a percent. Not because machines are fast, but because they are extraordinarily restrained. Within seconds, lids descend, seals tighten, and the outside world is locked away for months, sometimes years of stability. Yet the system still doesn't trust itself completely, because what if something invisible slipped through? As sealed jars accelerate forward, they enter a final gauntlet of automated inspection. Vision systems scan label alignment faster than the human eye could ever track. Checkwares search for deviations so small they would feel meaningless in your hand, but here they matter. Then comes the quiet enforcer of modern manufacturing, the rejection arm. Without hesitation, anomalies are swept off the line. No debate, no second chances.
Consistency is not a goal. It is a requirement.
By the time you pick up a jar, it has already survived dozens of silent eliminations. But the journey isn't over, because consistency must now cross oceans. Producing Nutella is difficult. Producing the same Nutella everywhere is an entirely different challenge. Pallets rise, robots wrap them, logistics networks activate. Yet shipping a chocolate hazelnut spread introduces a new adversary: climate. A jar traveling through Mediterranean heat faces a very different reality than one headed toward a northern winter. So distribution becomes an extension of engineering itself. Routes are optimized, storage exposure modeled, thermal risks evaluated.
Because if texture shifts during transit, everything upstream was wasted. And that leads to a profound realization.
The factory never truly ends. It stretches across highways, cargo ships, and supply chains, all working quietly to protect a sensory experience most people consume in seconds. Which brings us back to the question we opened with. What actually makes Nutella feel so impossibly smooth? Now you're ready to see it. That silk-like movement you see when a knife glides through Nutella is not accidental. It is engineered beneath the threshold of human perception. Earlier, we hinted at a number, around 20 microns, smaller than what your tongue can individually distinguish. To grasp how extraordinary that is, consider a single human hair, roughly 70 microns wide. The particles inside Nutella are often several times smaller. When they reach this scale, something remarkable happens. Your brain stops interpreting them as particles and begins interpreting them as creaminess itself. Smoothness, it turns out, is not merely texture, it is a neurological illusion, an agreement between physics and perception. But achieving that illusion demands global agriculture, precision roasting, microscopic refining, thermal engineering, laboratory validation, and logistical discipline. All so that when you open a jar, there is no surprise, no variation, no thought required. Just familiarity, just pleasure. Perhaps the most remarkable part of all. Millions experience this engineering masterpiece every single day without ever realizing the scientific orchestration behind it. So, the next time that knife glides effortlessly through the surface, remember, you are not witnessing simplicity. You are witnessing one of the quiet triumphs of modern food engineering. The world around you is filled with systems this precise, hidden inside products so familiar, most people never stop to question them. But once you see the engineering behind them, you can't unsee it.
If you enjoy stepping beyond the surface, beyond the label, and into the extraordinary processes shaping everyday life,
Subscribe and join us as we continue opening factory doors most people will never walk through. Because the next time you pick something up off a shelf, you might finally understand what it really took to place it there.
And trust me, some of the upcoming factories are even more unbelievable.